Alright, hey guys, it's Miss Summers with your notes today about station models. So these notes are a little different in that we don't have a PowerPoint. So what I'm going to do, I'm going to fill this in with you and you're just going to follow along. Alright, so if at any time you need to pause the video to catch up, that's totally okay. Alright. So we've been talking about weather and atmosphere and how things like pressure and humidity can change the weather. So now we're going to look at how we tell other people what the weather is and how we can use those means of communicating to figure out what is likely to happen to the weather. So a station model, I'm going to do my very best to use my very best handwriting for you. Referee. So a station model is first and foremost a picture. It is a visual representation of weather conditions. So what is the weather like at a given time? So a station model is going to change from day to day and hour to hour. So you might have a station model. They usually make station models for places like airports because it's important to know what the weather is at an airport, and it's going to constantly be changing. And the idea is that you look at the older station models to predict what the next station model is going to look like. So a station model basically looks like this. It's a very simple picture with a set of numbers around it and some shapes and lines. So anybody can draw. These are pretty easy, but you have to know what they all mean. So we're going to start with the numbers first. There's usually going to be 3 numbers. All right, this one in the top left-hand corner is going to be our temperature, just how hot or cold it is. So if it's 71 or 73, that's pretty comfortable. The number directly below that on the bottom left-hand corner is going to be our dew point. Remember, dew point tells us what temperature the air would need to be cooled to in order for dew to form, which basically gives us an idea of how humid it is. More on that later. And our last number is this top right-hand number. It's always going to be 3 digits, and it's sort of misleading. We'll talk about it in the next section, but this is our air pressure. So we are going to use that to determine if it's high pressure or low pressure. Now let's look at some of these other gadgets around here, these other little symbols and doohickeys. Let's just work our way around this way, shall we? So this line, sometimes this line will be here, sometimes it won't. Sometimes it will be facing the other way, so like going up a hill instead of down. This tells you the barometric tendency. Basically, is the air pressure rising or falling? Now, as you can probably guess, in this one, because it's sloped down, like you're rolling down a hill, if you were going this way, that's falling air pressure. All right, let's move on. This circle is the central part of any station model. They're all going to start with a circle. And however much that circle is shaded in is cloud cover. So if it's half shaded in like this circle, it is half cloudy. About 50% of the sky is cloudy. If it were all the way shaded in, that would be overcast. If it's not shaded in, that is clear. All right, so let's continue to move clockwise. Sometimes you will have symbols in between your temperature and dew point. Sometimes you won't. That is weather conditions. So this is going to be things like precipitation. Is it rainy? Is it snowy? Is there a thunderstorm? And we'll get to those at the last part of these notes. And last but not least, from this station model, you'll have a line. Sometimes the line will be coming from this way. It might be coming from that way, or this way, or that way. It all depends on wind speed, and wind direction. So, think of this like a compass. This is north, south, east, west. If the line is coming from here, the wind is coming from the northwest, And these little doohickeys on it tell you how fast it is, the wind speed. So generally, two longer lines like this represent 10 knots each, so that would be 20. Moving on to how we look at some of these numbers on this station model, because some of them aren't quite so straightforward. The temperature and dew point that's just whatever number it is, but air pressure is sort of tricky. My goodness. In a station model, air pressure is measured in millibars instead of inches of mercury. So normally, air pressure is going to be somewhere between 980 and 1020, 1030, somewhere around there. Now, on a station model, you might remember, well, this is 107. That is completely different from that. So what is that? Is that super low air pressure? No, it's not. We actually are going to change that number on the station model to get what the actual air pressure is. All right, so air pressure, just to remind you, not a bad idea to write this down. Air pressure is in the top, almost forgot my left from my right. Air pressure is in the top right-hand corner of this station model. So that's where you're going to look for it. If the number is above 500 in your station model, you are going to put the number 9 in front of it and add a decimal between the ones and tens place. So let me give you an example. Let's say I have the number, let's say 982. Well, 982 is above 500, so I'm going to put a 9 in front of 982, and then I'm going to put a decimal in between the tens and the ones place, so before the last number. So 982 on a station model actually means 998.2 millibars, right? Now, what if it's less than 500? Very good. If the number is below 500, we're not going to put a 9, we're going to put a 10. And we're going to do the same thing with the decimal. So let's use the one from the example you have in front of you. 107. So I'm going to write 107 right here, put a 10 in front of it, and then my decimal. So my air pressure is not 107 millibars, it's 1010.7. So let's do a little practice with that. Pause the video for these as you go along, and when you come back, we'll go over what the right answers are. All right, so we're back. 820. I'm going to look, and I'm going to determine, is it above or below 500? 800 is above, so I'm going to put 9 in front, 820, and my decimal. All right, 104 is below 500, so I'm going to put a 10. So 10, 104, and a decimal. So 104 becomes 1010.4. I'll be there in just a minute. Thank you, Mr. Kosal. Happy birthday to Mr. Kosal, by the way. All right, 212. That is below, below 500. So below is 10, 2, 1, 2, decimal, and this last one, 9993, decimal. Check your answers, make sure they're all right. If you have questions, write them down, and you can ask me after your notes. Moving on to the back side of the notes. Pressure and trends. So this is all sort of,
At this time, could we have Chris Brown's homeroom, Mr. Bush's homeroom, and Ms. Morris's homeroom? Those those seniors that wish to have individual cap and gown pictures report to the office.
Congratulations to the seniors. Super close to graduation. That's exciting. All right. So pressure trends, dew point, humidity. This is all going to be a review of stuff you already know. So pressure trends. If air pressure is falling, so that means the line looks like this underneath the air pressure number, then bad weather is most likely on the way. If air pressure is rising, then clear weather is on the way. Remember, high pressure, air sinks, no clouds. Low pressure, air rises, clouds form. That's what you'll look at. All right. Dew point, temperature, and humidity. Dew point will always be lower than or the same as the air temperature. It will never be higher. That is physically impossible. That would be crazy. We can't do that. So your dew point is always going to be lower or the same as. And basically, we went over this yesterday with humidity. If the dew point is closer to air temperature, it is more humid. So on the example on the front, with the air temperature being 73 and the dew point being 71, that's super humid. That would be very muggy. The air is very moist. If the dew point and the air temperature are super far apart, it is less humid. It would be drier and more comfortable. So if I look at these, which one is more humid? I'm going to compare these two numbers. So 50 and 42, that's a 12-degree difference. 78 and 75 is only a 3-degree difference. So this one is more humid. This one is less humid. Easy peasy lemon squeezy, right? All right. And last but certainly not least, let's go over some other important symbols that you might see either in the middle, in the circle of your station model, or to the side where precipitation is. All right. Our first one are going to be dots. They can either come in 1, 2, or 3. Having 1 dot means it's raining. 2 dots means moderate rain. Handwriting is starting to go here. And then 3 dots is going to be heavy rain. That's sort of the characteristics of a station model. The more symbols there are, the more of that thing there is. Okay? So, rain's a good one. We're going to have that a lot now here in spring. But if you took this class back in December, you might have seen this one. These little asterisks represent snow. So 1 asterisk is just regular snow, moderate snow, heavy snow. And let's see. The last one I'd like you to know is a super fun one. It's my favorite, and it's going to lead us to our next couple days. It looks like an R with a little arrow attached to it, but it's like very geometric. The lines are very straight. This represents a thunderstorm. And the reason I say it leads us to the next part of our unit, over the next 3 days, we're going to be talking about severe weather, and thunderstorms would fall into that category. Okay? All right. Our next symbols I want us to go over have to deal with the center of the station model and the wind speed and direction. So you have these. If the circle is clear, the sky is clear. Half shaded in, 50% cloud cover. And you can do this in any variation of fraction. Usually you're going to see something like this. If it's only a quarter of the way shaded in, like this, like you took 1/4 of the pie, that means 25% cloud cover. And vice versa, 75%. All right, so that's your general trends for clouds. And then the last thing I'd like us to go over is wind speed. All right, so the way the line is going shows us the direction it's coming from. So this wind is coming from the east in this example. each one of these larger lines is going to represent 10 knots, and then you would simply add them. If you see one that is like a little half version of that, well, what is half of 10? It's 5 knots. And you just add them up until you get whatever your wind speed is. So for example, this would be equal to 10 plus 10 plus 5, which is 25 knots. Right? So for our next assignment, you're going to show me that you've done these notes and ask any questions that you have, and then we will have some chance for you to practice reading these station models. Thank you.